Welcome back to Demolition Worker. Today we face the absolute ultimate challenge, dismantling the legendary Antonov and 124 transport monster piece by piece. This colossal machine stands as the largest operating military transport aircraft in the entire world right now, dominating the vast sky. Our primary focus for this operation is its incredibly complex and massive 24-wheel heavy-duty landing gear system. Destroying these reinforced titanium steel axles will require pure mechanical power and extreme precision from our best heavy hydraulic hammers. Before we begin the actual destruction, let us take a moment to appreciate the sheer scale of this engineering masterpiece. The Antonov was designed to carry unimaginable payloads across continents, requiring a landing gear capable of absorbing immense physical shock. Each wheel assembly is a marvel of Soviet-era engineering, built to withstand extreme pressure during rough and heavy landings. We have positioned our massive excavators around the aircraft, ready to initiate the systematic teardown of this beautiful flying giant. Safety protocols are strictly enforced today, as the tension stored within these massive struts could release with devastating explosive force. Our crew carefully inspects the main struts, identifying the optimal strike points for the hydraulic hammer to break the joints. The first step involves removing the outer layers of protective casing surrounding the primary titanium axles of the landing gear. Sparks fly as industrial cutting torches slice through the thick aviation-grade aluminum panels, hiding the beast's inner mechanical skeleton. We must clear all debris to give the hydraulic hammer a clean and direct path to the solid titanium core. Look at the size of those massive rubber tires, each one taller than a grown man and incredibly heavy today. The excavator gently lifts the first tire away from the assembly, revealing the incredibly thick steel brake housing hidden beneath. One by one, the 24 massive wheels are systematically detached and rolled away to our designated scrap processing zone. Stripped of its rubber shoes, the naked landing gear looks like the complex metallic skeleton of a prehistoric steel dinosaur. Now comes the true test of raw power against advanced metallurgy as we target the main titanium support beams today. The hydraulic hammer moves into position, its massive steel chisel gleaming under the bright sunlight of the active demolition yard. The operator takes a deep breath, aligning the heavy strike point directly with the thickest section of the titanium axle. The incredibly powerful machine delivers its very first crushing blow against the hardened metal surface of the aircraft suspension strut. A deafening metallic clang echoes loudly across the vast demolition yard as the hammer meets the reinforced titanium steel axle. Surprisingly, the thick titanium axle completely absorbs the SAF impact without showing any visible signs of cracking or structural failure. This incredible resilience perfectly demonstrates exactly why this legendary transport aircraft could safely land with hundreds of tons of cargo. The determined excavator operator quickly adjusts the hammer angle to target a potentially weaker joint in the complex suspension assembly. Repeated heavy strikes begin to chip away at the outer protective coating, slowly exposing the raw, shiny metal hidden underneath. We can clearly see the immense mechanical stress building up within the thick structural supports of this massive landing gear. The relentless pounding continues without any pause, sending violent shockwaves through the entire remaining fuselage of the giant transport plane. Small metallic fragments suddenly burst outward like dangerous shrapnel as the outer casing finally begins to fracture under extreme pressure. Our heavy machinery is being pushed to its absolute physical limits by the stubborn strength of this Soviet engineering marvel. The crew decides to temporarily halt the hammering process to carefully inspect the microscopic fractures forming along the main axle. We bring in specialized thermal cutting lances to strategically heat the thick titanium joints before applying more blunt mechanical force. Intense bright orange flames aggressively lick the cold steel surface slowly raising the core temperature of the massive suspension strut. This extreme thermal shock treatment should theoretically make the hardened metal significantly more brittle and susceptible to our hydraulic hammer. Thick black smoke billows upward into the clear blue sky as residual hydraulic fluids completely burn away from the heat. The thermal cutting team carefully steps back to safe distances, signaling the heavy excavator operator to resume the brutal assault. The massive hydraulic hammer strikes the superheated titanium axle with renewed aggression and absolutely terrifying raw mechanical kinetic braking power. A sharp cracking sound finally pierces through the noisy construction site, indicating a major structural compromise in the primary joint. We can clearly observe a massive deep fissure rapidly spreading across the glowing red surface of the thick central axle. The relentless mechanical monster delivers another devastating blow, completely shattering the weakened titanium support beam into several jagged, heavy pieces. This incredible victory over the main axle allows us to finally access the intricate inner workings of the suspension system. Dozens of smaller hydraulic cylinders and complex control arms are now fully exposed to our aggressive and destructive demolition tools. These smaller components are easily crushed by the heavy steel jaws of our secondary material processing shear attachment machine today. Watching these precision-engineered aviation parts being reduced to twisted scrap metal is both fascinating and slightly heartbreaking to witness. Every single piece of valuable aerospace-grade titanium and aluminum will be carefully sorted for future industrial metal recycling purposes. The sheer volume of high-quality material recovered from this single landing gear assembly is absolutely staggering to comprehend today. We now turn our full attention to the massive central pivot joint that connects the gear to the main fuselage. This critical connection point features some of the absolute thickest and strongest reinforced steel plating found on the entire aircraft. Our primary hydraulic hammer operator carefully positions the heavy chisel directly against the massive securing bolts of the pivot joint. The deafening rapid-fire impacts of the giant hammer violently shake the ground beneath our heavy steel-reinforced safety boots. One massive steel bolt finally shears completely off, flying through the dusty air and crashing heavily into the dirt below. This successful break creates a vital opening for our powerful demolition shear to bite deeply into the thick mounting bracket. The heavy shear slowly closes its massive steel jaws, applying thousands of tons of crushing hydraulic pressure to the metal. We can hear the terrifying sound of thick aviation steel tearing and groaning under the immense, unstoppable mechanical crushing force. The massive pivot bracket suddenly snaps in half, violently releasing decades of stored mechanical tension in one explosive metallic bang. A huge cloud of dark industrial dust quickly engulfs the immediate area as the heavy metal components collapse downward today. As the thick dust slowly clears, we can finally see the completely severed connection point hanging from the aircraft belly. The mighty Antonov transport plane has now officially lost one of its primary massive 24-wheel landing gear legs. Our dedicated ground crew quickly moves in to secure the massive fallen debris using heavy-duty industrial steel lifting chains. A second large excavator carefully drags the destroyed suspension assembly away from the dangerous drop zone for final material processing. We must safely extract the highly valuable titanium cores from the twisted wreckage of the shattered landing gear support struts. Specialized cutting teams meticulously slice away the mangled outer aluminum layers to reveal the precious solid titanium hidden deep inside. The raw strength of this aerospace material is truly astonishing, resisting even our most powerful industrial plasma cutting torch systems. It takes considerable time and immense effort to properly separate these exotic metals for the highly lucrative scrap recycling market. Meanwhile, the primary hydraulic hammer moves to the opposite side of the massive aircraft to begin the process all over. The second landing gear assembly presents an identical, formidable challenge of reinforced titanium steel and complex mechanical suspension engineering design. We apply the valuable lessons learned from the first extraction to dismantle this side with much greater speed and efficiency. The massive hammer strikes with surgical precision, targeting the specific structural weak points we identified during the previous brutal demolition. Thick steel bolts and heavy titanium brackets shatter much faster under this highly optimized and strategic blunt force mechanical assault. The repetitive rhythm of destruction echoes beautifully across the yard, a mechanical symphony of raw industrial power tearing through metal. Massive chunks of shattered titanium rain down upon the dusty concrete floor, creating a steadily growing mountain of valuable scrap. Our heavy loaders continuously scoop up the jagged metal fragments, transporting them directly to the waiting fleet of transport trucks. Each fully loaded truck carries away tons of premium aerospace-grade alloys, destined to be melted down and completely repurposed. The sheer scale of this massive Antonov demolition project requires seamless coordination between all of our heavy equipment machine operators. Watching the giant hydraulic shear effortlessly slice through the remaining thick aluminum struts is incredibly satisfying for our entire crew. We have successfully removed all 24 massive wheels and completely destroyed the complex titanium landing gear suspension system today. The mighty transport aircraft now rests heavily upon temporary steel support structures, permanently grounded and stripped of its strong legs. This challenging operation has truly proven the absolute superiority of modern hydraulic demolition equipment over legendary Soviet aerospace engineering design. Even the thickest reinforced titanium axles eventually surrendered to the relentless and crushing power of our massive industrial hydraulic hammers. The ground is now completely covered in twisted metal, shattered bolts, and pools of dark hydraulic fluid from the wreckage. Our cleanup crew works diligently to gather every single valuable piece of scrap metal scattered across the vast demolition zone. We utilize powerful industrial electromagnets attached to excavators to quickly sweep the dirt for any remaining hidden steel shrapnel pieces. The pure titanium fragments must be collected entirely by hand, as they are completely unaffected by our magnetic lifting equipment. Examining a broken piece of the main axle, you can clearly see the incredibly dense crystalline structure of the titanium. This specific alloy was explicitly formulated to survive the absolute extreme stresses of landing a fully loaded flying cargo monster. Breaking it apart required us to push our heavy demolition machines to the very edge of their operational mechanical limits. The successful destruction of this complex landing gear marks a major milestone in the complete teardown of this giant aircraft. We still have the massive fuselage and enormous wings to dismantle, but the toughest mechanical challenge has been completely conquered. The sun begins to slowly set over the busy demolition yard, casting long, beautiful shadows across the remaining metallic carcass. Our exhausted but highly satisfied crew finally powers down the massive roaring excavators after a long day of brutal destruction. Silence slowly returns to the scrapyard, replacing the deafening symphony of hydraulic hammers and tearing metal we heard all day. The sheer amount of pure mechanical energy expended today to break these titanium joints is absolutely difficult to fully comprehend. We have successfully transformed a critical piece of aviation history into a highly profitable pile of recyclable raw industrial materials. This incredible process perfectly highlights the fascinating and endless life cycle of heavy industrial machinery in our modern global recycling economy. Next time, we will aggressively attack the massive jet engines of this grounded beast using even larger and heavier equipment. You definitely do not want to miss the spectacular destruction of those incredibly complex and powerful aviation power turbine plants. Thank you for watching Demolition Worker. Please subscribe for more incredible teardowns. We will definitely see you next time. Goodbye.